Hello, I'm Carlos Bird. This is
Max Wellman, and I'm Katie Whitmore.
and Justin is off screen. That's Justin. For our data science project, we looked at border crossings data. This is from the Bureau of Transportation Statistics, and it's the same data that we've been looking at for a lot of our statistics courses, except for this is the updated January 2025 version. So there's a lot more recent data in the data set. If you look at the data source tab on the website, we discuss some of the specific variables that are covered in the data set. We're especially interested in the month and year variables for the purpose of time series, and we're also interested in the port name, state, border, and measure, because those will help us break up the data to analyze it and put it on a map so we can graph it as far as like number of data points. We'll get to that later. Uh, yeah. So we also clean the data a lot to get it to a format that'll work for analysis. The data set contains both observations for like single individuals as well as vehicles. So we went ahead and split that data into two separate data sets. So we can have one data set for just the people and one data set for just the vehicles, because those are going to have different implications and different analyses. So to talk about the geography and mapping, I have Katie over here.
Okay, now I'll talk about the maps. So I made some maps in Power BI. And they're separated out by passenger crossing for the first map, and then vehicle crossings for the second map. And I also included some closer zoomed in pics to be able to get a closer look at all the different locations across the US in terms of passenger crossing. And I don't know if we're logged into Power BI, but I did include the actual dashboard, which if you click on that, if you scroll over the bubbles, you can see the exact amount of crossings for that latitude and longitude, which is what I used to map the geographic location. And then I also included slicers so that you can judge it by the year and months of all the years of the data that they collected and by the different types of crossings. So specifically, like for vehicle, you do bus crossings or train crossings and just see the numbers for that and how it's changed, and like what location uses it more versus other locations. So I just created an interactive map along with the pictures that you can just look and observe, where they've crossed and how many at different locations throughout the US and the borders.
Talking about the graphs, various different types of graphing, these types of graphing with people over time. So we can see all the measures that people use are mainly just to visualize the data. These weren't used for any statistical tests or to derive any statistical significance from them. It's just to kind of illustrate the types of data that we have here. We also do this for vehicles over time as scatter plots. And then we broke it down in some of our charts and bar plots by month and year. So breaking it down by January, February, March, April, something like that. And so we can see that that personal vehicle passengers, at least for people, are the highest amount. Their personal vehicles are obviously the highest by month as well. We see that reflected in both the month and the year. The aggregator did and collated and break it down by measure, but by both vehicle and people, see that um, uh, Mexican, the U.S.-Mexico border has a lot more crossings, but the U.S.-Canada border has a lot more regular intervals, peaking in the summer months and dipping in the winter months. We think that this is due to uh, summer breaks and various different breaks in that code as well. And we can see broken down by port. We're not really able to glean too much information here, but this is just kind of again to visualize the different data between the different ports there as well. We see a similar thing with the measures as well. Personal vehicles are the highest amount of crossings in between those. We also noticed something distinctly that we decided to call the COVID drop. the year 2020. Obviously, the COVID-19 pandemic hit its full stride. And we can see a severe decrease and drop off in January and February of 2020, and we see it kind of recovered as well off that. Something interesting to note is that the measures, excluding personal vehicles, as we can see here, they don't show the cyclic patterns between the summer and winter months, as well as they're fairly consistent, fairly regular, and we posit that this is just because of the increased amount of online commerce and online shopping in those regards. For more information, we've linked the code down below.
This is Max. I did the models. As you can see, I did models for both the Mexican border and the Canadian border, as well as for the total border crossings. And for this, I did a time series prediction using Sarima, which is essentially a seasonal time series prediction. So, it predicts the time series as well as, there's seasonal patterns as well. And as you can see for the Mexican border, it's a lot more less seasonal than the Canadian border is, which is very strongly seasonal. And these models are not necessarily going to be very accurate because border crossings is something that can't really predict it with the past because it depends a lot on the current administration, and Trump's administration will probably have a lower immigration than these models might predict. All of these models do predict a downturn in immigration, so they might be accurate anyway. I also used a logistic model as well as a CART model to model whether or not a particular crossing was from Canada or from Mexico. And these models were kind of accurate, but the no information rate was extremely high, so it's difficult to say exactly how accurate they were. And they were mostly useful for detecting differences between the different borders and like what kinds of crossings they have. For example, what was it? People who cross from a bus are a lot more likely to be from the Mexican border, it looks like. Yes. Yeah. The CART model was significantly more precise than the logistic model. And it was also slightly more accurate. There was a very insignificant difference in sensitivity, but they were mostly very similar.
Looking back at all this data, there's a lot of very interesting trends. So we can see stuff like on the southern border, we have a lot fewer ports, but there's a lot more crossings per port. So the northern border, they're a lot more evenly distributed, many more ports, but very few crossings each. We also have seen these interesting patterns that are different between the two borders. So the more like seasonal cyclical data in the Canadian border compared to the Mexican border, which is a little more staticky and volatile, it looks like. We also see some interesting long-term trends like the COVID drop that we mentioned, as well as some changes that appear to happen in line with American presidential administrations, as well as a dip smaller than the COVID drop, but still noticeable around 9/11. So that'll be up on one of the other graphs. We also see some very interesting predictions when we go to the time series. We can see that our model predicts crossings to continue to decline, but level out a little bit. And even in the future predictions, we're seeing a lot of the continued cyclical seasonal stuff in the Canadian border and a lot of that kind of staticky data in the Mexican border. There's also a lot more of a precise confidence interval on the Canadian border, probably because of that cyclicalness. compared to the Mexican border, which is a lot less confident. There's going to be a lot of more interesting trends. This data only goes until January 2025, so it doesn't have data relating to the most recent administration, which has major changes in immigration and foreign travel. So if we have more updated data later this year or next year, it's likely that we'll see some very interesting different results if we do this analysis again. It could also be interesting for future research to look into bringing in other outside time series variables. So we could look at how this interacts with climate data, or how this interacts with population data, or anything that's geographic and or time series. But for our project, that's what we have.